Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. S.N.S. Rajlakshmi College of Arts and Science. In this series, we are already seen about what are the techniques we are using in artificial intelligence. Now we will see the technical requirements. So in this series, we are going to develop a robot using some of the techniques we are using. So the technical requirements we are using, there are Python 2.7 or 3.5 with NumPy, Scientific Pi, Math Flow library and scikit learning installed. So next one is a robotic operating system, that is a ROS, the computer running Linux for development or a virtual machine running Linux under Windows. So next one is a Raspberry Pi 3 or a similar single board computer like BeagleBone, Black, Android and similar. So Windows Ubuntu 16.04 is used for the example and illustration. We are not using the GPIO or special interface on the PI3. So an Arduino Mega 2560 microcontroller are also we are using in this to develop the robot. First, we introduce the robot and development environment. So, in this series, we are going to develop one robot that name is a Tin Man. So, it's look like this in this picture. So, it's centered around picking up toys into an interior space. So, our robot has a solid base with two motors and track for driving over a carpet. Our steering method is the tank type. So, or differential drive where we steer by sending different commands to the track motors. If we want to go straight ahead, we set both motors to the same forward speed. If we want to travel backward, we reverse both motors the same amount. Turns are accomplished by moving one motor forward and other backward, which makes the robot run in place, or by giving one motor more forward drive than the others. We can make any sort of turn this way. In order to pick up the toy, we need some sort of manipulator. So I have included a 6-axis robot arms that imitates a shoulder, elbow, wrist, hand combination. That is quite dexterous, and since it is made out of standard digital servos, quite easy to wire and program. Here we see the development environment of our robot. The entire robots run on one battery. You may want to split that have a separate battery for the computer and the motors. This is the common practice, and many of my robots have had separate power for each. Make sure if you want to connect the ground wire of the two systems together, I have tested my power supply carefully and have not had problem with temperature or noise. Although I don't run the arm and drive motors at the same time. If you have noise from the motors upsetting the Arduino, so and you will tell because the Arduino will keep resetting itself. You can add a small filter capacitor of 10 across the motor wires. Next we see what are the software components we are using in our robot. So the basic operating system for the robot is Linux running on a Raspberry Pi 3 SBC. As well said, we are using the ROS to connect of our various software components together, and it also a wonderful job for taking care of all the funky networking tasks such as setting up sockets and establishing connection. It also comes with a great library of already prepared functions that we can just take advantages of, such as a joystick interface. The ROS is not a true operating system that controls the whole computer like Linux or Windows does, but rather it is the backbone of communication and interface standards and utilizes that make putting together is a robot a lot simplifier. Next one is a Python. So Python is a general language for this purpose for two great reasons. It is widely used in the robotic community in conjunction with ROS, and it is also widely accepted in the machine learning and AI community. This double whammy makes using Python irresistible So the Python is interpreted language which has three amazing advantages for us. So we come to the end of this section. So artificial intelligence techniques have revolutionized problem solving across various domains, from machine learning and deep neural networks to natural language processing and computer vision. These techniques have demonstrated remarkable capabilities, their application ranging from predictive analytics and personalized recommendation to autonomous systems continue to reshape industries and enhance efficiency. Thank you.